Hello, it's Ben Holcomb here. I'm Associate Professor in Mechanical and Mechatronic Engineering at UTS and Faculty of Engineering and IT. I'm down at Tech Lab in the Vibration Lab. And this video is the second of two videos about the SAM1 automatic impact hammer, which is on the bench just here. I have another video which explains what's in the box, how all the cabling and everything connects together. So I'm already at the point where I've got the SAM1 powered. I've got the USB cable connecting it to the laptop here. I've got the box out with the software in there, but we don't need to worry about the software. There are some screws in there to mount, spare screws to mount the SAM1 if we want to mount it to some sort of a clamp or whatever. Importantly, this is the dongle that we need. So this is the USB key here, and I'm going to take that one out and plug that in my USB port. If it's been installed properly, the software, the light will come on, which tells us that the PC has recognised the dongle. The PCs in the Vibration Lab that are available on the booking system have all had SAM1 installed. In the box there's also some beeswax, and there's a couple of things in here that are interesting. There's a small mass here, which is an Xtra head expander mass for the back of the SAM1 to give it some more weight or mass, which improves or increases the force on the impact. And there's also a small rubber red tip here which can be mounted to the tip of the hammer. I'm not going to do it, but it will connect to the underside onto the tip of the hammer, and that will change the tip stiffness, making it a longer duration tip if we wanted to excite over a shorter frequency range. Put those ones back in the box. So everything's set up. There's some lights flashing on here which indicates we've got a connection. We've got power, as I mentioned, to the SAM1. First thing in the software in the laptop we need to do is start the TMCIL IDE, and all of these things should load into the wizard here to indicate that we've got communication protocol set up between the USB port on the laptop and the device. This is a normal look for this. Once that's running and looks sensible, no error messages, no warnings, we close that one. Actually, that just establishes the communication portal. Then we can launch the SAM GUI off of the either the start menu or the taskbar, and in the absence of any warnings here, there may be warnings if we don't, for example, have the dongle connected, or if the cable hasn't been connected to the hardware, there'll be some warnings and this will close down. But we've got a connection here, SAM1 is connected, and this is the way that the GUI looks initially. If we have a connection, we can push the start button down here and the device will start to do some impacts. I can't do that, I beg your pardon. The first thing I have to do is set the 0 position. That's important, my mistake. So if we go back to looking at the hammer, we can see that I have control over the hammer tip either manually here, or if I want to do this remotely, I can also connect the laser pointer to the laptop via another USB cable, a USB port if I had another one. I don't have one on this laptop, but I could use a USB extension if needs be. Can connect this one, and then I can use the left and right arrows to go up and down as well. So if I'm away from the laptop, I can do that remotely essentially. So what I'm doing is setting the 0 position so that the software knows when the tip is just in contact with the structure. And this isn't a particularly good setup here because I'm not perfectly normal to the structure. Really, I need to be perfectly normal to the structure, but it's good enough for today actually. Maybe we could just put this one in here. This might be a slightly more normal arrangement if this was my structure. And then I hit the OK button in the software, and the hammer will retract from the structure. Now it's ready to start, and I can push the start button, and the hammer is going to complete impacts according to the various settings that I have on the GUI. There's a time interval between impacts of 1.5 seconds, so I can either make that shorter to a second, for example, or if I need to wait for my acquisition system to collect more data, then I might need to wait 4 seconds between impacts. So that's that. I can either do it using the knob, or I can enter it manually with the keyboard. Then there's the stop angle. This is the angle at which the hammer essentially stops and then like freewheels into the target. When I make that angle slower, lower, I should say, then you can see that now I'm impacting the structure, whereas before I was stopping too early. So at a stop angle of 2, I'm not actually striking the structure. If I make that 1.2 or 1.11, now I'm striking the structure. If I make it 1.5, I'm still striking the structure. We have to be careful that we select these two parameters, so the velocity of excitation and the stop angle, in combination. So now I've changed the velocity, and because the hammer tip is travelling faster, whereas before at 300 millimeters per second I wasn't striking the structure, now even with a stop angle of 2 I'm striking the structure. So for a faster velocity I actually would stop earlier. Now if I go to 3, now you can see for 600 I'm not striking the structure. If I go to perhaps 900, maybe you need to go higher. This has not been rehearsed, as you can tell. Okay, so even if I go right, oh, now I'm back to 100. So the message is we have to tune these parameters in combination to get the kind of impact that we want on the structure. We're looking for in modal analysis for a very sharp impulse of excitation. So as well as using these parameters here to control, we need to have a look at the data acquisition system and look at the force time trace on the acquisition system, make sure we have no double impacts. And to control double impacts for certain parameters here, we might drive it harder. We can, to get higher force levels, we can actually also go to the advanced settings and control some other parameters like the hammer tip deceleration. So at the moment we have the maximum deceleration. This is the deceleration of the hammer after it reaches the stop angle. The pullback acceleration is the thing that's going to help us avoid double impact. So if we accelerate faster away from the structure for more mobile structures, we should increase the pullback acceleration and possibly also the pullback velocity. So now you can see, if you look at the hammer dynamics, it's accelerating and moving very quickly away from the structure. Okay, so we can also do a single hit if we want to just explore one impact on demand, or when we push the start button, it's just going to keep striking the structure. If we have settings that we like and we want to save those and try some different settings, say we were doing a measurement campaign where we wanted to strike it with a light impact, then a hard impact, and we weren't going to change anything else, i.e. the mounting of the hammer itself, the location of the target, we might want to save the settings so that we can load up the old settings, do some runs, load up some new settings, do some more runs. So we're checking, for example, for structural nonlinearities by striking the structure at different impact levels on two different scenarios. And then there's the triggering. So we can also use triggering. We can define the number of impacts with triggering. Now it's essentially waiting for an external trigger rather than just free running, just tap, 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 tap. In the case of triggering, if we turn on the triggering, which I've done here, and the number of impacts it should do once the trigger threshold has been overcome, we need to connect to the device itself, to the trigger input, an inbound TTL signal. So this would be the trigger input. And this output here, which I've not necessarily mentioned immediately on this video, this is the force measurement that's going to our data acquisition system. And to make sure we're collecting calibrated units, we should refer to the manual here and the paperwork also in the documentation here, which tells us about the force sensitivity for the force hammer. So for different tips, we have different transducer sensitivities, and we need to define those or include those in our acquisition system. That pretty much concludes the software operation of the NV-Tech SAM1 modally tuned impact hammer. Thank you.